Today's lesson will be a continuation of 2-4, slopes of parallel and perpendicular equations. So we're still going to be looking at parallel and perpendicular lines. However, we're going to be looking at the equation of the line rather than looking at the points that we get from a line. We're going to look at the equations. So this again will be a little bit of a review of some Algebra 1 content, and some of it will be pretty familiar to you, and you'll probably need a little bit of a refresher on these topics. So the first thing we're going to look at are the two forms of equations of lines. So when you were in Algebra 1, you learned about slope-intercept form. So do you remember what slope-intercept form is? Most students, if they remember nothing else from Algebra 1, they tend to remember slope-intercept form. So what does slope-intercept form look like? It is y equals mx plus b. That is a super common form that we see in Algebra 1. It's really nice because it tells us information without having to really work for it. It tells us what our slope is, right? So m is slope. So whatever number is in front of x is our slope. So it tells us that right away. And then it also tells us our y-intercept. Hence the name slope-intercept form, because it's telling us what our slope is and what our y-intercept, and it tells us right there. We do not have to do any rearranging, any solving like we will with our next form, which is standard form. So standard form makes us work a little bit. And standard form looks like this. So do you remember what standard form looks like? This tends to be one that we forget a lot of the time. So you might have a guess of what this form is, but you might not know. So standard form looks like this. AX plus BY equals C. And the thing about standard form is that it really doesn't tell us anything about the line just by looking at it. So A doesn't represent anything. B, the capital B, it's not actually y-intercept like the lowercase b is here. It really doesn't tell us too much. We have to work a little bit to figure out information from this form. So what we have to do when we get something in standard form is we must change it into slope-intercept form. So we have to change this into y equals mx plus b form, which is slope-intercept form. So that's going to be one of our jobs today, is to change this form into this form. So rearrange some things, and then that way we'll be able to see our slope. And of course, remember, we're talking about slopes of parallel and perpendicular lines. So slope is what we want to know. We want to know what the slope is for each of these equations, which is why we're going to have to change it into slope-intercept form. So let me give you an example here of how to go from standard form to slope-intercept form. So now this is definitely something that you learned in Algebra 1 last year. However, it tended to be kind of a harder topic sometimes. Just some people got a little confused with it. So let's just go over and refresh our memories on how to go from standard form to slope-intercept form. So here's an example of standard form. Okay. So that's standard form. I have my A is 2, my B is 3, and my C is 4. So I want this to look like that. I want y to be by itself, and I want the x term to be over on the other side. So I have to do some rearranging. So I'm rearranging this the same way I solve equations. So this y needs to be alone. So all of this stuff needs to go away. So my very first step, and this is always my first step, is to move your x term to the other side. So I'm going to subtract 2x from both sides, and basically like picking up this x term and moving it over to the other side of my equal sign, okay? Now I can do this by inverse operations. Whatever I do to one side, I do to the other. And of course, if you remember how to do this, and you're like, oh yeah, I remember that, that was easy, you can totally fast forward this part if you remember how to do this and you feel good about it. But if you don't, you definitely want to pay close attention. So I'm going to just highlight my steps over here just so we have a little summary. So I'm going to move my x term over. Okay, so I'm moving that over. I want it to look like this, and this has the x term on the right side, so I'm going to move it over. So that goes away, so I got rid of it. I'm left with 3y equals, and here's where people get stuck. They see these two things right here, and how do I write those? Can I do 4 minus 2? Does that equal 2x? No, these are not like terms. You cannot combine these, okay? So we're still going to have two terms over here, but remember I want it to look like this. I want it to be y equals mx plus b. And in y equals mx plus b, the x term is written first. So I'm going to write my x term first. So I'm going to write negative 2x because there is a negative in front of that. That subtraction sign is a negative. So negative 2x. And then we get confused. Do I have this 4? Do I just write a 4? What should be in between that negative 2x and the 4? Since it's a positive 4, we write plus 4. And that is now my right side of the equation. Okay, but I'm not done. I have one more step. Is y by itself? No. So I need to get rid of this 3. How can I get rid of this 3 here? Inverse operations. I'm going to divide both sides by 3. Now, the thing is, though, I divide everything by 3. Okay? Everything gets divided by 3. So we're going to divide all terms. Okay, we're dividing all of the terms. So that cancels, and I am left with negative 2 over 3. We're not going to divide that and put a decimal. We like when slope is in a fraction because it tells us rise over run. We do not want it to be a decimal. So I am going to write negative 2 over 3x and I'm going to leave this as well as plus 4 over 3. I don't need to change it into a decimal. And now that's in slope-intercept form. So maybe you remember how to do this, and maybe you don't. So it would be good to just pay attention to this example so you can do this over and over again because that's what your practice is going to involve today. Now, this is Algebra 1 material, so of course we're in geometry now. So this is not all we're going to be doing. We're going to do some other stuff with it because our goal here, we're still trying to figure out if lines are parallel or perpendicular. So why do we need to get it into slope-intercept form? So that I can see what the slope is. So what's the slope of this equation? It's the number with x. So in this case, my slope is negative 2 over 3. So that is my slope. Okay, so it's a lot more work for standard form. That's why, standard form is not my favorite form. I like slope-intercept form. I'm going to give you an example of slope-intercept form and you'll see why it's just so much nice and easier. So let's say we have y equals 3 halves x plus 6, we'll say. So that is in slope-intercept form already. So I don't have to do anything, no solving, no rearranging. I can right away identify what the slope is. So tell me, what is the slope of this equation? It is 3 over 2. And my y-intercept is 6. So now let's compare. We have this slope here, and we have this slope here. So what can we say about these two? What kind of relationship do they have? Are they parallel? Are they perpendicular, or is there no relationship? So you should notice that they are negative reciprocals, so these two lines are perpendicular. All right. So that's pretty much what we're going to be doing today. Our goal here is to look at two equations. Rather than the coordinates, we're looking at the equations of the line, and we're deciding, are these equations parallel or perpendicular or neither? So the same way we did that with just looking at coordinates and using slope formula, we're going to do that with equations. And sometimes it can be super easy if they're both in slope-intercept form, and then sometimes it can be harder if one or both of them is in standard form. So let's take a look at some examples. And then, of course, you'll practice with this. So your main practice part is going to be this right here, where you have to get it from standard form to slope-intercept form. So that can be the trickier part just because it's a little bit more work. So let's start with our examples. You're going to be asked, same way you were with the first part of 2-4, is are the lines, or the equations of the lines, but we'll just say are the lines parallel, perpendicular, I'm just going to abbreviate, or neither. So are they parallel, perpendicular, or neither? So let's take a look. Let's start with an easy one, and then we'll work our way up. So an easy one would just be if my equations are already in slope-intercept form, right? So if they're already in slope-intercept form, then I can simply identify the slope and go from there. So if I have y equals 5x plus 2 and y equals 5x minus 1, I'm only looking for one thing. I'm only looking at the slope, which is the number that is with x. So my coefficient of x is my slope. And if I look at both of them, I see that they're both 5. So what does that mean? Are these lines parallel, perpendicular, or neither? Since they're the same slope, that means they are parallel. So same slope as parallel. So remember, that's your new fact that you need to know from yesterday's lesson. Same slope means parallel lines, okay? These are both already in slope-intercept form, so it didn't take a whole lot of work for me to figure that out, which is very nice. Let's look at another one. Let's say we have y equals negative 3/4 x minus 5. That's one equation. And we have positive 4/3x plus. Okay, so let's identify our slopes first. So what is the slope of the first equation? Negative 3/4. And what is the slope of the second equation? Positive 4/3. So what do we notice about those? They're not the same, but they are opposite, negative, reciprocal. So flipped and then the opposite sign. So that means they are perpendicular. Okay. So these I would consider kind of level 1 questions. It didn't take me a whole lot of work to find the answer. Just knowing that I have to identify what the slope is, and then knowing the relationship between parallel slopes and perpendicular slopes. So let's take a look at just a level harder problem. So we're going to have one that's not already in standard form for me. So that just kicks it up a notch. Let's say I have y equals negative 1/2 x plus 1 and 6x minus 3y equals 21. So this one's slightly harder because this one's in slope-intercept form, but this one's not. So I'm going to have to go back up here to my example and see how do I get that into slope-intercept form. So get the easy part out of the way. I'll see that, okay, look, the slope here is what? Negative 1/2. Now, it would be nice if I could just do the same thing here and say, oh, it's this, but it's not so simple because it's not in slope-intercept form. So I'm going to follow my example from the top of how do I get that into slope-intercept form. Whenever you're doing a math problem, you should, and you're not sure what to do, you should always be looking at an example to guide you, okay? Looking what happens at the example, how do I do the same thing to this new problem? So if I look at my example, I moved the x term over. That's my first step. So I'm going to come down here. What am I going to move over? This 6x. So I am going to subtract 6x from both sides. So I'm moving it over. Okay, that goes away. I'm going to bring down this y term here, same way I brought it down. Here, though, in this case, always bring down the negative sign with your y variable. So this is going to be negative 3y equal to negative 6x, okay, plus 21. So the same way I did it up here, negative 2x plus 4. So now take a look at the example here. What's my last step? What did we do up here? We divided all terms by this number here. So I'm going to come down here and divide everything by negative 3. Okay. A mistake I would see people do on problems like this is add 3 all over. We're not adding 3. This is not negative 3 plus y. This is negative 3 times y. So I have to divide by negative 3. So this cancels. And y equals, so when you're simplifying this, you're dividing. Okay, so negative 6 divided by a negative 3 is positive 2. Okay, if it was like the example up here, where when we look up here, 3 doesn't go into 2. So there's nothing I can do there. So I just leave it as negative 2 over 3. But down here, 3 does go into 6. So I can simplify that. If you can simplify, you always should. Always, always. So 6 divided by 3 is 2. And then over here, 21 divided by negative 3 is a negative 7. So minus 7. So now I have it in slope-intercept form, so now I can tell what the slope is. So what is the slope of this equation? It is 2. Okay, so now I check, all right? I have, this line has a slope of 2, this line has a slope of negative 1/2. Are they the same? No. Are they negative reciprocals? Yes. Yes, they are. If you flip 2, it's really 2 over 1. Okay, so when you flip it, it becomes 1/2. That's the reciprocal. So these are perpendicular lines. Perpendicular. And that's all. So obviously a little bit more work on this one. You will have a good chunk of problems where you do have to get them into slope-intercept form. So let's take a look at another example. I just want to give you Another type that you might see and how to work with that. Okay, so why I want to show this one is because it looks slightly different because there are no coefficients. So like X and Y are by themselves, there's nothing with them. However, we still can identify slope and we still would want to get it into slope-intercept form. So if I look at this one, it's not in slope-intercept form. This one is in slope-intercept form. People get confused though when they see this because they're looking for the number in front of X and they don't see a number in front of X. So what would the slope be if you don't see a number? Yes, the slope would be 1. M would be 1. So if you don't see a number there, I'm just going to kind of sketch one in. That means there's a 1. It's an understood 1. So your slope is 1. So let's figure out here what our slope is. So we're going to have to get it into slope-intercept form first. So same way I did up here, I'm going to move my x term over to the other side. So when I do that, it's going to become negative x minus x on both sides. Common mistake, forgetting about this negative sign. You need to keep that with your y. So that's negative y equals negative x plus 9. Okay, so it feels like we're almost done, but if you look, there's a negative sign in front of y, and that actually has to go away. Y is not alone yet. We need to get rid of it. So that's really a negative 1. Okay, so I'm going to divide everything by negative 1, which really means I'm just changing the sign of everything. So that's going to become y equals positive 1x. And we don't need to write the 1, we just write x. 9 divided by negative 1 is minus 9. Okay, so now what's our slope here? M is 1. Same way it was up here. So there's really an understood 1 right here. So both slopes are 1, so these lines are parallel lines. All right. I'm going to turn the page and I just want to show you, this is kind of the extent of our examples, but I want to show you some weird cases or just some weird ones that you might see so you're prepared for those. So remember in our previous lesson, I reminded you of what horizontal and vertical lines looked like. So I just reminded you, this is a vertical line. This is a horizontal line. And you can have those lines with equations. So some ones that you might see are if you have y equals negative 7 and x equals 2. Okay, this is different. I don't see a slope. It's not in y equals mx plus b. It just looks different. So what these are vertical and horizontal lines. So on a graph, these look like, and you may remember this or you may have forgotten, but if I were to graph y equals negative 7, it would be going through my y-axis at negative 7, and it would be a horizontal line at negative 7. Okay? And if I were to graph x equals 2, it would be a vertical line at x equals 2. All right, so what do you notice about these? These would be perpendicular lines. Okay, so these are perpendicular lines. Another weird one, if you had, say, x equals 2 and x equals 4. These would be 2 lines, and they would be going through 2 and 4, and they would be 2 vertical lines. So they would be parallel. So how can we remember that when I see something that looks like this, it's perpendicular? When I see something that looks like this, it's parallel? It's kind of like, look, same variable, parallel. Same slope, parallel. Different variable, perpendicular. Different variable, perpendicular. So like when you have your two slopes that are negative reciprocals, they're perpendicular. So that's just a way you can remember. So same slope is parallel. And remember, these two have a slope of undefined. All right. So those were just weird cases that I wanted to address in case you see those. So they look a little bit different than our normal examples. But that's all that I'm going to go over with you today. You'll practice with some problems. Most of your problems that you see will look like examples 1 through 3. However, you never know on a test or a state test if they would put a problem that looks like one of these. So that's why I wanted to make sure I showed you a couple of those. And then that is all for today's lesson.